this demo, we are going to use Oracle Analytics Cloud to demonstrate how we can address the data cleansing, feature engineering, and exploratory analysis stages of the data science lifecycle. I'm in the role of the researcher or the physician, and I have a table including all the stem cell donor data from our donor registry, and I would like to have a high-level overview over the donors' data. Before I start my exploratory analysis, let's have a look at the dataset editor. Here I can assess the quality of the data, I can make transformations, and I can also receive data enrichment recommendations from the machine. So here I can see a preview of the data, and at the top I can see the distribution of the values that are in each one of the columns. And for example, I can do feature engineering. I can also scroll to see the distribution I have within my data set, and I might come across examples where there will be data quality issues. For example, here for property ownership of the donor, I have null values and or missing values. And what I can do is I might want to replace that with unknown. So I just need to click on missing null values and type unknown. What it will do, it will replace the missing values with unknown value, like you see here. And once I'm happy with the results, I can go into my workbook to perform exploratory analysis to get a better understanding of what type of donor characteristics I have in the registry. And I will just switch to the dashboard that I've prepared for based on this data set. I see the number of donors, I see the number of donation centers, average years on the registry for my donors, and the geographical spread of donors, which is worldwide. Now, if I look at donors by ethnicity, I see that, for example, race F, which I know is a race where donors have a rare human leukocyte antigen matching, which is used to match the patients and donors for a transplant. And I see that I have a small number of donors. We also see the split by gender, and if we move down, we see that most of our donors are above 31 years old. I have a small number of donors below 31, which are the preferred, is the preferred range of age because of the highest success rate in transplants that we have seen and recorded so far. And then we see the number of donors who were contacted to recommit and to reconfirm they want to be in the registry. And we see that we have a number of donors who were contacted for more than 1 year, and we might want to contact them again sometime in the near future. Now, what I can do is take some actions from here and ask the marketing department to conduct a public campaign to educate the population on the importance of donating stem cells and the risks attached in order to get young donors and low represented ethnicity to register in our database. Now, the success of the stem cell transplant depends on finding the matched donor, but also on the donor availability, as the time taken from diagnosis to transplant is recognized to adversely affect the patient outcome. And on average, 50% of potential donors are unavailable for a variety of reasons. So it would be very useful for me to be able to predict every donor's availability in order to simplify the donor selection process and to minimize the risk of delays in the transplant. So I will ask the data scientist to build a machine learning model in order to achieve that. I'm in the role of the data scientist, and I got a request from the researcher to build a machine learning model that will predict the stem cell donors' availability to donate when they are contacted to do so. I will be using the Oracle machine learning environment in order to do all the steps in the data science lifecycle, from data exploration and data preparation up to model building, model evaluation, and model deployment. So my data set already resides in the autonomous database. It has 1,470 rows, and it contains data about the donors, mainly demographic data and health history information. The column or the target value is donor answer, yes or no, so it's a binary column. And Oracle Machine Learning is an environment that allows me also the data exploration part. What I have done here is to plot some visualizations in order to visualize the distribution of the data in relationship with the target variable, the donor answer. So you can see here the address change, distribution of the address change by the target value, and we can see that we have some null values in the address change. So we can also spot the data quality issues. And on the right-hand side, we have the distribution of the donor race by the target value, by the donor answer. We have also here some null values. What I will want to do next is replace those missing values with unknown, and I can also do some other data preparation steps. I can do feature engineering, any type of data transformation that I need. In my case, the dataset has only these two quality issues. The rest is in a good format in order to be used for my model. So what I do next is just replace the null values for address change to unknown and the null values of donor race with unknown. Once I do that, my data set is ready to be used for the model building steps. I will show you next how to do the model building using the AutoML user interface in the next step. I am in the role of the data scientist, and I got a request from the researcher to build a machine learning model that will predict the stem cell donors' availability to donate. I have already done the data preparation steps in Oracle Machine Learning, and for the next step of model building, model evaluation, and model deploying, I chose to use the AutoML user interface that allows me to build the model in a point-and-click user interface with no coding needed. What I need to do is just give a name to my experiment, select the data source where the data resides, then specify the target column, the column that I want to predict. In our case is donor answer, yes or no, and the prediction type. In my case it's a binary classification, and the primary key of the dataset table. I can further do some additional settings like selecting the number of models to be tested, the duration time, and then the model metric that will be used in order to evaluate the results. You will find here only the metrics that are specific to the prediction type chose above. And you can also choose the algorithms. I chose decision tree, generalized model, random forest, and support vector machine. I can also select the features to be used in my dataset. I removed from the feature list the donor age and donor age at registration because they are highly correlated and I want to get good results. So I have just removed them. Once this is done and I run the experiment, you will see the progress and all the actions that AutoML does for me. We see first the algorithm selection and then adaptive sampling, feature selection, and model tuning. All these 4 steps, which are usually a repetitive task in the data science lifecycle of a model, all these steps are done automatically. So AutoML will test for me the four models selected, and they will it will return me the results on this leaderboard that we see here. And as I can see, Random Forest is the best performing. If I click on the model name, I can also see the impact of each feature over the prediction. And I see that donor age at transplant request, distance to donor center, donor age, race, blood donation reliability, and years on the registry are the features that impact the most the prediction. On top, we have the donor age when he was contacted to donate, and the distance to donor center, which is quite, let's say, obvious. And then we can also see the confusion metrics, check the results and the actual versus the predicted values. Once I'm happy with the result, I have the possibility to deploy my model into production. I just need to give it a name. Let's say stem cell, just to be easier to follow, and then a URI, and I need to check shared in order for my model to be shared for use in production. I am back in Oracle Analytics Cloud in the role of the researcher. I have asked my data scientist colleague to build a machine learning model that would predict the stem cell donors availability in order to improve the donor selection process and shorten the time to transplant, which is known to adversely affect the patient outcome. The machine learning model needs to be registered in Oracle Analytics Cloud. We go on Register Model function, Machine Learning Models, and by selecting the connection to my autonomous database, I can see all the Oracle machine learning models that were built. I have already registered the model that I want to use. So now, once this is done, I can use Dataflow, a user-friendly interface that allows me to apply the machine learning model to my dataset. It looks like a flow made of different steps. The first step is to load the data. Then I can add a second step to apply the model, and then save the model or the results of the model in the autonomous database. Once I execute this, save it and execute, the results will be saved and available for use. In the next video, we will see how a dashboard based on these results will look like. I am back in Oracle Analytics Cloud. I am the researcher that I've asked the data scientist to build a machine learning model to predict the stem cell donors availability. I want to improve the donor selection process and shorten the time to transplant, which is known to adversely affect the patient outcome. The machine learning model was already registered, so I've used it to build this dashboard page. First, let's say I have a patient that needs a transplant and I have found 3 matching donors, ID 1, 2, and 3. And I can take an immediate action here to look at the results and first contact the matching donor who is predicted yes with a high probability to be available. And if I look at the results, I see that donor number 3 is predicted to say yes, while donors 1 and 2 are predicted to say no with a quite high probability. This will likely shorten the time to transplant, and we will get faster to the donor who is available to donate. Looking at the data and the distribution, we see that almost 3% of the donors were predicted to respond positive to a donation request by the model created for me. I can also see that both male and women, male and female, would say yes to a donation request with a bit higher percentage for male, which is a good thing because male donors are known to be to have a higher success rate for the transplant. Looking at the age when the request for donation was made, I can see that people aged 16 to 35 or 36 are more likely to say yes, which is a good thing again. We know that the age of a stem cell donor is one of the most important characteristics that influence the transplant success rates, with the younger donors associated with better survival rates. Also, people more close to donation centers tend to say yes more, and people with higher education would respond positive. We can also see the availability by the recommitted response, availability by address change, and availability by whether they responded to the health history questionnaire or not, the one that they should fill in when they join the stem cell donors registry. And let's say we run this model monthly. And for example, donor 3 is a yes donor this month, but next month he might be a no donor. There are many reasons. He might have changed his address far from the donation center, or he got older and he's not willing to donate anymore. And we may come back to the prediction table, and I will just filter and get the donors that are predicted to say no. I can actually take an action here and contact the donors who are predicted to say no, just as a regular check to cross-check if they are still willing to donate. Another way I can use this prediction dashboard is to look at donor ethnicity that have a rarer human leukocyte antigen tissue type. And for example, because I'm a researcher, I know that race E donors have a rarer tissue type, and this makes it harder for us to find a good match for some of the patients compared to others. And to resolve this problem, we can contact again the no donors that have this rare matching tissue to double check and make sure if those donors are still willing to donate or not. We can also educate the population internationally to add more people from those minority ethnic backgrounds to the STEM register to provide a larger pool of potential donors and to help all patients have an equal chance of finding a match.